So let's add this to our last lesson from last day, example 3. All you want to do is draw yourself a rectangle that is 2 squares or rectangles across by 4 squares or rectangles down. You can freehand it. If you're artistic, you can make the squares all the same size or the rectangles all the same size, whatever. You see, one possible application of permutations with repetitions is what are called pathway problems. And it's a neat enough application. I'm going to give you a couple of these on your test. So I like this question. I love this question. Nerdly cool. And it asks this. On the following grid, which is 2 by 4, how many different pathways can I take from A to B, assuming I can't backtrack? Because if I could backtrack, then the answer is infinity, because I can start going in a circle. But assuming I always have to move closer to my target, how many different pathways are there? Well, let's look at one such pathway, maybe the simplest such pathway. The simplest such pathway would go east, east, south, 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 south. Right? And I think, Steph, any pathway is going to have to go east twice, somewhere along the way, not necessarily both in a row, but somewhere along the way, and south 4 times. In fact, call me silly, won't any pathway have 2 E's and 4 S's? That's a word. How many letters in this word, grand total? How many E's? How many S's? How many paths are there without bothering to count them all and draw them all and see if I've missed any? Can you evaluate that, please? I did it in my head, but I don't know if I'm right. Double check. Is it 15? Ooh. So that's a neat application. Having said that, questions from the homework. I gave you a bunch to try, and some of these were nasty. Some of these I may even have to bail out and look at my solution key like I did last time. So the homework was page 391, 392 actually. Any of these you want me to go over that you were going, holy schmoly, I have no idea how the heck to get this. I'll pause a little longer here for our latecomers to figure out what's going on, for people to pick up their pencils, etc. Yeah, you're asking questions about the homework. You just made my day. Might almost forgive you for being late. Maybe not. Okay. 6C. All the adults are all together. You know what? I'm going to pretend that that's kind of a weird looking Scrabble tile that has adult 1, adult 2, up to adult 4. There's 4 adults. And all the kids, I'm going to pretend that's a weird looking Scrabble tile that has child 1 all the way up to child 5. Those are the tiles in my grab bag. How many tiles are in my grab bag? So the first thing I would say is there's 2 factorial ways to choose a tile. How many ways can I mix up those 4 adults? 4 factorial. How many ways can I mix up those 5 kids? That should be it. I have no idea what the answer is, but if you, well, 2 factorial is 2, 4 factorial is 24, 5 factorial is 120, so it should be 2 times 24 times 120. Is it? Someone want to try that? Does that make sense the way I explained it? Right? That grab bag analogy is, it's one of my fallbacks. In fact, there are 2 fallbacks that I go to in this unit. 3, I lied, 3. Drawing a blank. I'm good at drawing a blank, yeah. Grab bag analogy, that's all for fundamental counting principle. And then today's lesson, we're going to learn something called combinations, and I'm going to give you the idea of a bucket. Imagining pulling things out of a bucket, because it works nicely. Okay. D says if the adults are all together, now you would have all of those in a bag to pick from. How many tiles? 1, 2, 3, 4, 5, 6 tiles to pick from. Oh, and how many ways can we mix up the adults? Because it didn't say that they had to stay in the same order. I think that would be D. Yeah, I think. Pretty sure. Any others? Rest of these went good? So you'll definitely get something like number 8 on your test. They'll give you some kind of a word with repetitions in it. I'll probably give you 1 or 2 on the multiple choice tricky-ish ones like this, where there's some kind of a restriction. And we say permutations with restrictions is what we call that, where, oh, the certain letter has to be at the front, or these 2 letters got to be side by side. But I'm not going to go cuckoo for Cocoa Puffs way overkill. Okay. I won't call them easy, but I won't call them A- level questions. They'll be C plus B minus-ish. Any others? Okay, can you then get out your lesson set and go to lesson 4, combinations, one of my all-time favorites. So today we're going to look at what are called combinations. Example 1 says this: if 5 sprinters compete in a race, how many different ways can the medals for first, second, and third place be awarded? Well, you have a first place medal, a second place medal, and a third place medal. How many choices are there for the person that finishes first? How many runners are there to pick from? Okay, once someone has finished first, how many runners are there to pick from for the second one? 4, then 3. I think it's obvious you can't finish first and second and third at the same time. It's obvious things don't repeat. Or you could have said from 5 permutate 3. Or 5 factorial over, what's 5 take away 3? 2 factorial. And can you see that that does simplify to 5 times 4 times 3? Anyways, what is 5 times 4 times 3? 5 times 4 is 20 times 3. There are 60 different ways that 5 runners can finish first, second, and third. Does the order matter here? Is first different from second, different from third? Absolutely. This is an example. So does the order of finish matter here? Totally. This is an example of a permutation of 5 objects taken 3 at a time. 5 PR. What if it's not the Olympics? What if it's the qualifiers, and the 3 fastest qualify for the Olympic relay team? But you don't care whether you're first, second, or third, Nicole. All you care is in or out. Here, the order does not matter. You just want to know, did you make it or not? How many different relay teams can be formed? Well, you can visualize the 5 sprinters as a word, where 3 of them get a yes because they finished in the top 3, and 2 of them get an N because they finished in the bottom 4 and 5. How many letters are in this word? How many Y's are there? How many N's are there? What's the answer? Yes, you need to go to your calculator. 5 factorial is 120 divided by 6 is 20 divided by 10? Yes? 10. Does the order matter here? Okay. This is an example of a combination of, can you all underline the word combination? In a combination, the order doesn't matter. In a permutation, the order makes a difference. But in a combination, the order doesn't matter. This is an example of a combination of 5 objects taken 3 at a time. From 5, form a group of 3. Who cares what the order is? Okay? An unordered arrangement of distinct objects is called a combination. And we write it this way. From n objects, combine, or I think choose, letter C begins the word choose, are Holly, how many objects were we picking? How many sprinters were there grand total? You know what? This equation is going to have an n factorial on the top because that's how many objects there are grand total. Holly, what do you notice about these two numbers? What do they add to? What do they add to? Meant to be really easy. Add to. Yes, say it louder, please. You mean they add to the total number of objects? How many sprinters were we choosing? This is going to be n factorial over r factorial n minus r factorial. This formula is also on your formulas sheet. This is also on your formulas sheet. And, conveniently, it's built into your calculators. You see, next to this 10, this is really 5, choose 3. 5, math, left arrow, there's the choose option. 10. What you'll have to realize is whether order matters or not. Most of the time it will be very obvious whether order matters or not. When it's not, you'll just have to think about it, and I'll tell you which one's order does not matter in shortly. Okay? So this is on your formula sheet. This is the long way. It's built in. You do have to be able to do it the long way occasionally. Turn the page. How many different committees of 3 people can be formed? We'll turn the page now? Really? That much long a delay when I say turn the page? Turn the page. Here we go. How many different committees of 3 people can be formed from 7 people? Have they suggested somehow that it matters whether you get picked first or second or third in this question? We'll assume order does not matter. So there are several ways to write this. 7, choose 3. And what this means mathematically is 7 factorial all over 3 factorial 4 factorial. You notice the bottom 2 numbers always add up. How many are in? How many are out? And you can either type that into your calculator or you can use the choose feature. But can all of you right now use the choose feature and find what is 7 choose 3? Find where it is on your calculator. Oh. What is 7 choose 3? 35. Now look at A and compare it with B. B is similar. Steph B asks, how many different committees of 3 people can be formed from 7 people? Exactly the same as before. If the first person selected serves as the chairperson, the second as the treasurer, and the third as the secretary. Katie, does the order that you're picked matter here? This is a permutation. Right? Because the first person, the second person, the third person. This is going to be... Or you could go like this. We're picking 3 people. I got 7 choices for the first person, 6 choices for the second person, 5 choices for the third person. Or, Jessica, you could use the permutation formula, which was 7 factorial all over 7 minus 3 factorial. What is 7 minus 3? What is 7 minus 3? Anyone? What is 7 minus 3? Huh? Yeah, over 4 factorial. Whichever way, please find this. What is, if I'm picking in order, How many, Nathaniel? You need to practice this on... Hey, guys, let's follow along on our calculators. All of us. 210? Okay. 210. C. If a group of 7 people consists of 3 males and 4 females, how many different committees of 3 people can be formed with 1 male and 2 females? It says, think, you must choose 1 male out of the group of 3 and 2 females out of the group of 4. Okay. Is there any hint here of order or who gets picked first or anything like that? No. But there are 2 separate groups, yes, Cassandra? Males and females? Here is the trick that somebody showed me when I first learned how to teach this, and I went, oh, this totally works. Put your pencils down for a second and watch. Whenever they give me a multiple group question, I draw a bucket like this. And I have males and females. Don't write this down yet. Just watch how I put this together. How many males are there grand total? Put a 3 right there. How many females are there grand total? Put a 4 right there. How many males do we need to choose? Read the question carefully. How many females do we need to choose? 3, choose 1. And means multiply because it's the fundamental counting principle. 4, choose 2. Draw the bucket and then write the equation. My fallback in choose questions is always going to be draw a bucket. And if you raise your hand and you say, Mr. Dueck, how do I? I'm going to say, have you drawn a bucket? If you haven't, you're silly. And then once you've done that, because Nathaniel, this takes practice to get good at your calculator, go 3, choose 1 times 4, choose 2. You had 18? 18. Is that okay so far? Choose. Look at D. Suppose this group of 7 people with 3 males and 4 females, so same group. But now we have to have at least 1 male on the committee. This is an example of what we call different cases. If you have to have at least 1 male, what are the possibilities? Can someone tell me every possibility? 1 male or... What does the word at least 1 male mean? And look at your group size. You can have 1 male or 2 males or 3 males. Can you have 4 males? No. Because there's only a total of 3. But you have to know what the words at least or at most or less than or more than mean in English. So this says at least. What that really means is it's going to be 1 male or 2 males or 3 males. Let me say that again. 1 male or, hey, what does or mean? Two males or, what does or mean? Okay, there's going to be a plus sign in here and here. 1 male we already just did. We said 1 male is going to be 3, choose 1, and 4, choose 2. Here's my bucket right here. 2 males. From 3 males, choose how many? From 4 females, choose how many then? Think about it. Carson, 1, because we're picking 3 people grand total. Or, from 3 males, choose how many? And From 4 males, for 4 females, choose how many? 0. Get your calculators out, but then stop. Don't start typing yet. Do you notice, Cassandra, these are kind of symmetrical looking? I never type all 3 of these in at once. I'll tell you what we're going to do. Type the first one, which you all still have, yes? So let's write 18 plus. Then just go, instead of retyping from scratch, go second function, enter. Change the 1 to a 2. Change the 2 to... That's way faster than going math, back arrow, blah, 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 blah. You know what 3 choose 2 times 4 choose 1 is? 12 plus. Then again, go second function, enter, and I'm going to change the 2 to a 3 and the 1 to a 0. If I have to have at least one guy on the committee, how many different committees can I form? 31. Example 2. Evaluate that. Oh, I got a problem. What's the highest factorial that my calculator will go? 70 was the cutoff. That's where it crashed. How many factorial do they want me to go here? Oh, wait. Do those 2 add to 100? Then you know what this really is in disguise? This is really 100 choose 3. Try typing that into your calculator. Will your calculator handle that? Does it? Oh, what do you get? Read me the digits one at a time, Tyson. So there is a kind of a workaround. Although the strict factorial function cuts off at 70, the permutation and the choose, the combination functions can handle more. The software was tweaked. B. Solve that. What choose 2 equals 21? Well, there's the guess and check method. How about 5? I'm guessing here. 5, math, choose 2. Nope, too small. How about 6, choose 2? Nope, too small. How about 7, choose... Okay, the answer is 7. Let's prove it. Let's prove it. How, if I'm going to give you a question like this on your written, I'm going to give you some kind of choose or permutation or factorial equation to solve. What we're going to do is we're going to plug this into the choose equation. We're going to plug this into this thing. So it's going to be, what are we trying to find? N factorial all over 2 factorial n minus 2 factorial. That equals 21. Does that match this? Yep. Oh, by the way, this is why I told you it was worth memorizing. What is 2 factorial? 2. So on the next line, I'm not going to write the exclamation point anymore. It's not that I canceled it or anything like that. I actually just evaluated it. But 2 is weird because it is its own factorial. But if there was a 3 there, it would become a 6 on my next line. It would not become just a 3 with no more exclamation mark. Okay. What I want to do actually is I want to move the 2 over to this side by cross multiplying. I want to leave these 2 here, but the 2 is being divided. I'm going to multiply over on this side. This is going to become a 42. Now what? Can I just cancel out the exclamation mark? No. I asked myself a question. Which one's bigger? Which one is bigger? n or n minus 2? N, I'll start to expand that. This is going to be n times n minus 1 times n minus 2. I'll stop there because that's a factorial that will cancel out with the n minus 2 factorial on the bottom equals 42. Tyson, can I cancel? Is it factored? Then I can. And in fact, Tyson, what I end up with is n times n minus 1 equals 42. Sabrina, now what? Yeah, what's that? Get rid of brackets, FOIL, multiply. So are you saying my next line is going to be... I agree. Hey, Sabrina, what kind of an equation is this? It's quadratic. How do I know? It's got a squared. How do I solve a quadratic? Before I do anything else, before I start to factor, what do I have to do first? How would I do that here? Minus 42. Sabrina, because I'm running out of room, I'm going to cheat. I'm going to go like that, and then like that. Ah, wasn't that clever? I'm looking for two numbers that multiply. Will this factor? Yeah, it will. I'm looking for two numbers that multiply to negative 42 and add to negative 1. This factors into n minus 7, n plus 6 equals 0. Ryan, what are my roots? But Ryan, do you get 2 dates? Why? Can I have negative 6 objects? No. Sorry, Ryan. Keep working the phones, but no. What are the best examples of combinations of unordered arrangements? Poker, card hands. This is a pretty good poker hand right here. Straight flush, it's the best poker hand. If I was playing, it's a royal flush, if I was playing poker, I wouldn't care whether I got the ace first or last, or whether I got the king first or last. All I want to know is, once I've got 5 cards, do I have them or not? Are they in the group or not? Card questions, gambling, poker are great examples of combinations where the order doesn't matter. Turn the page. I first of all have to make sure that you all know what a deck of cards looks like. So a standard deck of cards has 52 cards, 1 for each day of the week. 4 suits. If there's 52 cards and 4 suits, how many cards in each suit? Do the math. How many cards in each suit, boys and girls? You need to know this, so it's not 12. 13, ace through king. Okay. The 4 suits are clubs, diamonds, hearts, and spades. Half of them are black, half of them are white. So how many black cards are white, red? How many black cards are there in the deck? 26. How many red cards are there in the deck? What's a face card? Okay, Jack, Queen, King. Those are some terminology I'm going to use. Let's see if we can do a few card questions here. First of all, how many different 5-card hands can be formed? How many cards are there grand total? 52. Choose 5. If we're playing 5-card poker, how many different possible hands are there? You may have wondered, those of you that play poker. How many? Evaluate it, please. I think it's just shy of 3 million, if I recall. Nicole, can you read me the digits, please? Okay. Now I'm going to show you why that bucket trick I gave you is so nice, because now we're going to start dividing this deck of cards into groups. So it says B. How many different 5-card hands can be formed that consist of all hearts? I'm going to draw a little bucket. And this bucket's going to have 2 groups. Hearts and not hearts. The symbol for not in math is a horizontal line above your group. If I see a horizontal line, You can also just write out Sabrina, not hearts, but if you're looking for some nice shorthand, H and not H. Shannon, how many hearts are there in the deck? Think about it. That's why I asked this question a little while. How many hearts are there in the deck? 13. How many non-hearts are there in the deck? Think about it. 39. How many hearts am I choosing according to this question? 5. By logic, then, how many others am I choosing in this question? That's kind of a trick question. 0. Can you see what the equation is going to be? What choose what times what choose what? Not 5 choose 13. 13 choose, right? You got a bigger number, choosing a smaller number. For, right? 13 choose 5, and 39 choose 0. Stop. Stop. All of you stop. Shortcuts worth memorizing, because this is a lot of typing. Can all of you right now find 39 choose 0? What's 39 choose 0? 1. What's 5 choose 0? I'll give you a hint. 1. In fact, what's anything choose 0? I'll always write it there because I like that this comes from the bucket, but I won't bother typing the times 1 in. Okay. Oh, what's 39 choose 1? Go second function, enter, and change the 0 to a 1. What do you think 5 choose 1 is? 5. What do you think 10 choose 1 is? 10. That's also handy if I'm only picking one object. Often I won't type in the choose. I just know it's the number of objects. Okay. Anyways, what's the answer here? How many different 5-card hands can be formed that consist of all hearts? What do you get? So I'm not going to type times 39 choose 0, but I'm going to go 13 choose 5. Is it 1287? Then why didn't somebody tell me that when I asked what do you get? Oh, how many suits are there? How many different suits are there? Carson, what do you call when all the cards are the same suit? How many suits are there? So there's a total of that many ways to get a flush, divided by the total number of 5-card hands. That's the odds of getting a flush. Right there. Okay. How many different 5-card hands can be formed that consist of all face cards? Face cards, non-face cards. Got a little picture of a deck of cards here. How many face cards are there? What's a face card? Jack, Queen, or King. How many suits are there? So 3 face cards in each suit, 4 suits. How many face cards are there? How many non-face cards are there then? Do the arithmetic. 40. How many face cards am I choosing here? 5. How many non-face cards am I choosing here? What's my equation going to be, Tyson? What choose what choose what? And means multiply. Am I going to bother typing in 40 choose 0? No, but the other reason I like it is there's a built-in error check. 12 and 40 is 52, 5 and 0 is 5, 52 cards, choose 5. I haven't missed any. What is the answer here? 792? Okay. Hey, what if instead of 5 face cards, what if I wanted 3? It'd be 12 choose 3, 40 choose 2. Very doable. Oh, let's mix and match a bit more. D. How many different 5-card hands can be formed that consist of 3 hearts and 2 spades. All right, bucket. This time my bucket's going to have 3 categories. Hearts, spades, everything that's not a heart or a spade. Others. Amanda, how many hearts are there in the deck? Okay, by the way, you need to know this pretty quickly here. I'm hoping you guys have played cards. I'm going to ask you lots of card questions because it's the application. Sorry, how many, Steph? How many spades are in the deck, Amanda? How many others are left? 26. How many hearts do they want me to choose here? Katie? 3. How many spades? By reason, how many others then? 0. Katie, what's my equation going to be? What choose what choose what choose what? Times. And 26 choose 0 is 1, so I probably won't bother typing that, but I'll put it there because, again, Leah, I have a lovely built-in error check. 13 and 13 and 26 is 52 cards, choose 5 of them. What is 13 choose 3 times 13 choose 2? $22,308. Okay. How many different 5-card hands can be formed that consist of exactly 3 hearts? How many groups are mentioned here? Hearts, and then I guess non-hearts, so 2 groups. Hearts, non-hearts. Ready, Amanda? How many hearts are there in the deck? Woohoo! And since there's 52 cards grand total, how many non-hearts are there in the deck? Thank you. Love it. Jessica, how many hearts are we choosing? And then by logic, how many non-hearts must we be forced to choose? Can you see the equation popping out of here? $13 choose 3 times $39 choose 2. Psst, psst, psst. Look up. Do you have 2 chooses in a row? How about like this? 13 choose 3 times 39 choose 2. Hey, it's almost already typed for me. Is it 211926? 211,926. Look at E and then carefully read F. What's the key thing that makes F different? Steph. Cases. Can all of you underline or highlight the word at least? What does at least 3 hearts mean? What possibilities does that include? I'll give you a hint. 3 hearts or... Did you say 2? I hope you said 4, because at least would mean more than. Yes? 4 or 5 or... Oh, no, not 6. Why? Because it says 5-card hand. You know what? Let's make a little heading then. We have 3, 4, 5. Did you hear me say or several times, Katie? What does or mean? Now, I already got the 3. It's 13 choose 3 and 39 choose 2. I'm clever enough to look at my previous question. I could redraw the bucket, but let's see, Andrew, how good am I? Andrew, can you tell me what I'd write here for 4 by just tweaking this bucket slightly in your head? Oh, and now let's pick 5 hearts. 13 choose. And that's also why I always write, even though it's times 1, can you see there's a nice pattern that I can also spot? Oh, going up by 1s, going down by 1s. There, it's nice and symmetrical. The extra 1 second of writing is worth it in my mind. Oh, and again, I would do each of these individually rather than all 3 at once. So I would do something like this. Well, I already know it's 21, 1, 9, 2, 6 plus second function enter. Make that a 4. Make that a 1. 27,885 plus second function enter. Make that a 5. Make that a 0. 1287. And then I would add those 3 together really quickly. And I get 241,098. Yo. No, I always will though, and trust me, later on I'm going to show you when we get to probability questions that it provides a built-in error check. I'm going to show you a way that you can check you haven't missed anything. So for that whole quarter of a second of writing, I think it's worth it. But I won't take marks off, but I'm telling you, I still always do. I find for these questions, it's way too easy for me to accidentally either double count or miss one object if I'm in a rush. Can you please, if you would be so kind, turn to lesson 4 in the workbook, which is combinations part 1, page 397. Page 397. Actually, page 398. They're walking you through combinations still. That's a complete lie. How about page 399? This is what I was looking for. Here it is. The number of combinations of n items taken r at a time is that. And then it says, note, the NCR key on a calculator can be used. If you have a scientific calculator, by the way, it's also got an NCR. And if you get tired of math, one thing I don't like about the TI is the probability functions are so hidden. Math, left arrow down, it's a lot of typing. It's faster, actually, on a scientific one. I have to admit. This is one time where the technology, better technology, isn't as good as the cheaper technology. Okay. Example 1. 3 students from a class of 10 are chosen to go on a school trip. How many ways can they be selected? Does it seem to suggest that the first kid is different from the second kid is different from the third kid? No. So does order matter here? No. How many students? 10. Choose 3. Which is what? Okay. Is that right? Okay. In factorial notation, it would be 10 factorial over 3 going, 7 staying. You all just did 10 choose 3? Yes? Can you now, what is 10 choose 7? $120. Can you do 10 choose 2 right now, please? 10 choose 2. 45. What do you think 10 choose 8 is? Stop. No calculator. What do you think 10 choose 8 is? No? Okay, do it. It's going to be 45. Isn't it? Yeah. Let's do a group of 15. What's 15 choose 5? 15 choose 5. Now, as an equation, that would be 15 factorial over 5 factorial, 10 factorial. What's 15 choose 10? Is it not the same answer? Why? Because as an equation, that would be 15 factorial over 10 factorial 5 factorial. Isn't that really the same math? Or here's what we're really saying. If I have 10 people and I'm pulling groups of 3 out, by pulling a group of 3 out, aren't I automatically forming a group of 7 in? If I pull 4 people, 10 choose 4, that'll be the same as 10 choose 6. Because you can't form a group of 4 without accidentally forming a group of 6. That can also sometimes be a shortcut. You may notice when you're doing one of those at most or at least questions, oh, I just did 10 choose 3, and over here I'm doing 10 choose 7. It's going to be the same number. I can save myself some typing. Yeah, whatever. Lotto 649. You have to choose 6 numbers from 1 to 49, and the order they pick them doesn't matter. They give them to you in numerical order because it's easier to read, but you don't have to pick them in that order. How many different ways are there to get 6 numbers in Lotto 649? 49 numbers, choose 6 of them. If you wanted to guarantee yourself a win, how many different tickets would you have to buy? Just shy of 14 million, 13983816. Of all those different combinations of numbers, how many are the winner? Think about it, it's pretty obvious. 1. Chance of winning, 1 in. Chance of winning, that. Oh, chance of winning the grand prize. What if we wanted to find the chance of winning 5 numbers? You could figure out a way to figure out the odds of matching 5 of the 6. And you would say you can win by winning all 6 or 5 of 6. What does or mean? You would slowly start adding the odds together, which is why the odds are slightly higher than 1 in 14 million. A little bit better, but not much. Example 3, the Athletic Council decides to form a subcommittee of 7 council members to look at how funds raised should be spent on sports activities in the school. There are a total of 15 athletic council members, 9 males, 6 females. The subcommittee must consist of exactly 3 females. Skip A, skip B, let's go straight to C. And since there's more than one group, let's draw a bucket. Males, females. How did I know to go with a bucket here? They didn't talk about the order or anything in part C. They didn't say the first person is something or other. Okay. Ragjit, how many males are in the bucket grand total? 9. How many females? How many females do I have to choose? So by reasoning, how many males do I have to choose? Sorry? How many people are on the council? So if I'm picking 3 females, by default, how many males must I choose? 4. So read the questions carefully. Yes, yes, yes. What's my equation going to be? Which is what? Let's add a restriction. Let's add a condition. How many ways can you form this if Bruce, the football coach, must be included? Question, Katie? 26,520, or you could have just done it on your calculator and found it yourself. Just saying. Okay, D says Bruce has to be on the committee. We're going to combine fundamental counting principle and today's lesson. Bruce. How many ways are there to pick Bruce? 1. Now what would my bucket look like with males and females. Well, there's still 6 females to pick from. How many males are there left to pick from if Bruce is already removed from the pool because he has to be on the committee? How many females do we have to choose? It says 3. Ragjit, how many males are we choosing? Careful. Yes, because we already picked one, haven't we? It's going to be 1 times 8 choose 3, 6 choose 3. Will the 1 times make any difference at all? Then hopefully you're all clever enough to go second function, enter on your calculator, and just backspace and change the 9 choose 4 to an 8 choose 3. Okay, Bruce has to be on there. What's the answer, Itzel? I heard 120. What? 1120? Yes? So if they give me a restriction, like always, deal with it first, remove that from your grab bag, and then keep going. Turn the page. A few more card questions, because these are nerdily cool. We already did A. We said A was 52, choose 5, whatever the heck that was. I don't care. It was 2.6 million, roughly. How many will be all diamonds? Try this first one on your own. I'll do it up here. Let's see if we get the same answer. Yes? 1287? 2. 4 black cards and 1 red card. Black, red. How many black cards are there in the deck? 26. How many red cards? 26. I think 26 choose 4 times 26 choose 1, which is what? Which is a lousy poker hand because it gets you nothing. So it should be fairly high odds because it's a lousy poker hand. What? 3, what? 3. Carson, is 3 kings and 2 queens a good poker hand? Should be a smaller number then. Right? Shouldn't happen as often. Okay, let's draw our bucket. I'll draw my bucket up here. Now, this is going to have 3 groups. It's going to have kings, queens, and not king and queen. Others. Ready, Amanda? It's your moment to shine again. How many kings are there in the deck? How many queens are there in the deck? Okay, how many other cards are there in the deck that aren't kings or queens? Do the arithmetic. 52, take away 8. And I guess I want 3 of those, 2 of those, none of those. 4 choose 3, 4 choose 2, 44 choose 0, which is just a 1, so I won't bother typing that in, but I'll write it because it's nice and symmetrical. $24. Not many ways to get a full house king high. Kings and queens. That means that'll beat most poker hands. Not all of them, but most of them. You all right with this? I'll pause here. By the way, 3 kings would be 3 kings and 2 others. So 13 choose 3, 39 choose 2. Sorry, not 13. There's 4 kings. 4 choose 3, 48 choose 2. 4 choose 4, 48 choose 1. Probably very few number of 4 ace hand, because 4 aces is a pretty good hand. And we already did a flush. All hearts. Homework. Number 1, assume the order for pizza toppings doesn't matter. Number 2, number 4, five is good. 6 is good. 7 is good. 8 is good. 10 is good. Yeah, I'll pass on that for now. I think we'll stop there.